Assalamu alaikum. Today our topic is about algebraic representations of direct proportion. In our introductory video to direct proportions, I have given you an example, and in that example, I told you that in Pakistan, if we borrow books from a public library and are late in returning the books, we will be fined 15 rupees per day per each overdue book. Now this table shows the fine for an overdue book. Like per number of days, let it be X and its fine will be Y rupees. So per 1 day it will be 15. For 2 days it will be 30, and for 3 days it will be 45, for 4 days it will be 60s, and so on. Then later on in that video I have introduced a new term that was rate. So I will also use that same statement or acknowledge that we have a rate of y by x. So what I mean that if I have this 15 by 1, I will get what? 15 by 1, it will give me 15. Then if I have y by x for this column, then I will get 30 by 2. That will also give me 15. And then for this one, 45 divided by its respective x, that is 3. So it also give me 15. So for all such values of y by x, it will give us 15s. For every this, it will give us 15, which is a constant. So if we represent this constant of 15 with a k, okay, so let me represent this constant of 15 with k. Then y by x is equal to k, or I can also write it y is equal to k times x, where k will be not equal to 0. Hence, we come across a situation that if y is directly proportional to x, then y by x is equal to k, or y is equal to k times x, where k is a constant and k is not equal to 0. Okay, so this will be our main terms. You will have if y is directly proportional to x, then we have this, we will use these statements. Okay, then y by x is a constant, or y is equal to kx. Well, k will be not equal to 0. But wait a minute, what if I substitute k is equal to 0 in this? Then what you can say about the relations between x and y? So if you know the answer, pause the video and type its answer in the comment sections, or I'm gonna tell you about it, okay? Now to know the answer that if y is directly proportional to x, we can write its relation as y is equal to k times x, where k is a constant. And if we substitute k is equal to 0 in the equation, it would becomes as y is equal to 0 times x, which result us 0 times x will get us 0. This means that for any value of x, y will always be 0. In this scenario, there is no longer a meaningful relationship between x and y in the context of direct proportionality, because y does not change with x, it's simply always 0. Therefore, for k is equal to 0, y is always 0 regardless of the value of x. This is a degenerate case of direct proportionality, where the proportionality constant k being 0 indicates that y is identically 0 for on x. When we have seen this, that in this is x changes, y also changes. When in this relation, that if k is equal to 0, then we have y is equal to 0, and regardless of the value, if you keep on changing the value for this x, y doesn't change. So it will be as it is. So this is a meaningful relationship between x and y in this context of direct proportionality. So this means that regardless of the value of x, y will always be 0. In other words, there is no variation in y as x changes. So therefore, when k is equal to 0 in the direct proportionality equation, there is no relationship between x and y as we have over here. But when k is equal to 0, there is no relationship between x and y. They are simply independent of each other. So this situation is often referred to as a trivial case in direct proportionality. Okay, I hope this will answer the question. Allahumma salli ala Muhammad. Before I show you the graph for this table, I am using GeoGebra calculator suite to show you the graph of this one, but a little just note the values of x and y. So this is the number of days as we have in this table. So look at, we have 1, and for 1 day we have a fine of 15 rupees. So it will be for x, it will be 1, and y is 15. So then 2 and 30. So 2 and 30 will be point B. And then C, for x it will be 3 and respectively y will be 45. And then for D, its coordinate x will be 4 and y will be 60. And then 5, 75 you can note on. And then up to 10, we have 10, and for 10 we have 150. So you can see this. Now let's see how its graph can be drawn using this GeoGebra calculator suite. And now for those points, let's see the graph, and it will be like boom. So you can see the graph. So this is for point A, this is B, C, D, E, F, G, H, I, J. Okay, for 10 points, it is a straight line. So if someone asks you, we have 3 questions, that is y against x. What is the shape of the graph? So you can see that it is a straight line. Question number 2, does the graph passes through the origin? Yes, it is passing through the origin. You can clearly see that it is passing through origin. So to conclude, we have if y is directly proportional to x, then the graph of y against x is a straight line that passes through the origin. Okay. So in this class, we come to know that in algebraic representations of direct proportion, if y is directly proportional to x, then y by x is equal to k, or y is equal to k times x, where k is a constant and k is not equal to 0. And we also study that what if k is equal to 0, so you also come to know that then y and x has no relationship with each other. And in graphical representations of direct proportion, we came to know that if y is directly proportional to x, then the graph of y against x is a straight line that passes through the origin. Now keeping these 2 concepts in mind, and we will now solve some thinking time questions based on this direct proportions. So now it's time for question number 1. If y is directly proportional to x, is x directly proportional to y? Yes. If y is directly proportional to x, then x is also directly proportional to y. Here is an explanation. First, we need to understand the direct proportionality. When we say y is directly proportional to x, it means y is equal to k times x or some constant k. This relation indicates that as x increases, y increases in such a way that their ratio remains constant, as we have done, or I have shown it in that table of number of days in the book were due. So if I write this equation, y is equal to k times x, it can be rewritten to express x in terms of y just by dividing k on both sides. So I can write this equation y by k and dividing k also here. So this will cancel, and we will come up with x is equal to y by k. The interpretations of the rewritten equation x is equal to y by k shows that x is equal to constant, which is 1 over k times y. So it can also be written as 1 over k times y. This means x is directly proportional to y with a constant of proportionality 1 over k. As we have constant of proportionality k in this case, well, in this case we have x is equal to 1 over k times y. So this is constant of proportionality. Thus, to conclude this question, I would say that if y is directly proportional to x, then x is also directly proportional to y. So, if y is directly proportional to x, it can be represented as y is equal to k of x, then we can rearrange it to x is equal to 1 over k times y, which shows that x is also directly proportional to y. Okay, so first let me take an example, a simple example. Suppose that y is equal to 2x. This is the example. This means that for every unit increase in x, y increases by 2 units. Rearranging this equation, I can write it for x as x is equal to y by 2. So here x is directly proportional to y with a proportionality constant of 1 over 2. So x can be written as 1 over 2 times y. So the direct proportionality relationship is mutual. If one variable is directly proportional to other, then the reverse is also true. Fine? In this question, they say suppose y is directly proportional to x. If we plot the graph of x against y, will we get a straight line that passes through the origin? So in our first question, it's almost the same as our first question. They say that y is directly proportional to x. It means that the graph of y is equal to kx will passes through the origin. And when y is directly proportional to x, then x is also directly proportional to y. So yes, x against y graph will also passes through the origin. It's that simple. It's like our first question. It's not so different that much from our first question. So the answer is yes. If y is directly proportional to x and we plot the graph of x against y, we will get a straight line that passes through the origin. Here is why. Now, as I told you that understanding the direct proportionality, when we say y is directly proportional to x, it means there is a constant k such that y is equal to kx. This equation indicates that as x increases, y increasing proportionally, maintaining a constant ratio of k. And after rewriting this equation, y is equal to kx, it can be rearranged to express x in terms of y, like x, and dividing k on both sides, I will get this one. So this rewritten equations tell us that x is directly proportional to y with a constant proportionality of 1 over k. 1 over k times y. Now the graphical representation, graph of y against x. When we plot y is equal to kx on a graph with y on the vertical axis and x on the horizontal axis, we will get a straight line passing through the origin with a slope of k. We will get this straight line. Similarly, when we plot graph for x is equal to 1 over k times y on a graph with x on the vertical axis and y on the horizontal axis, we also get a straight line passing through the origin, and this time its slopes will be 1 over k in this case. Well, in this case, for y is equal to kx, its slopes will be k. Okay, so the conclusion is this, that since x is equal to 1 over k times x is a linear equation where the line passes through the origin of 0 and 0, this confirms that when you plot x against y for a directly proportional relationship, you will indeed get a straight line that passes through the origin. The direct proportionality ensures that the ratio between x and y is constant, leading to a linear graph. Now the next question, they say if y is directly proportional to x, then the graph of y against x passes through the origin. If the graph of y against x does not pass through the origin, is y directly proportional to x? Now, if y is directly proportional to x, we know that this means that y is equal to kx algebraically, where k is a constant of proportionality. For a direct proportionality relationship, the graph of y against x will be a straight line that passes through the origin. So this is because when x is equal to 0, y is equal to 0. Okay, so like if I put x is equal to 0, then I will get y is equal to 0. Okay, now if the graph of y against x does not pass to the origin, it means that there is an additional constant term in the relationship between x and y. In other words, the relationship is of the form y is equal to kx plus b, where b is not equal to 0. This represents a linear relationship, but not a directly proportional one. The constant b indicates a vertical shift from the origin. So when x is equal to 0, y will be equal to b instead of 0. Let me tell you something like y is equal to kx plus 2. Now for x is equal to 0, I am drawing table over here of 2, 3 numbers. For x is equal to 0, I will get x. So 0 plus 2, it will get me y is equal to 2. Thus, this line y is equal to kx plus 2 represents a straight line that intercepts the y-axis at y is equal to 2. And let me use GeoGebra calculator to show you graph or line that is y is equal to kx plus 2 with different values of this k. Fine. Now, this is the equation y is equal to kx plus 2, and we will see for different values of k from -5 to 5. So you see, just we got when x is equal to 0, y was equal to 2. So this is the one point, and as I told you that this equation represents a straight line that has a y-intercept at y is equal to 2. Now let me play this and you will see that for different values of k, it is always that straight. It is a straight line and it has always this y-intercept. Okay, and for different values of k, it almost keeps on changing, but it will never ever passes through this origin. When x is equal to 0, y is not equal to 0 because of this 2 or b. When this is not equal to 0, so although it will be a straight line, but it will never ever pass through origin. So this line indicates that x and y has a linear relation, a straight line, but it doesn't pass through the origin. So it is not direct proportionality. And if I take like an example like y is equal to 2x, if x is equal to 1, I will get y is equal to 2. And when I put x is equal to 0, y will become equal to 0. But for this case, let me write it as 2x plus 3. So when I put x is equal to 1, I will get x is equal to 1. I will get 2 1s or 2 plus 3, I will get 5. So when x is equal to 1, I will get this one. But I will never get y is equal to 0 when I put x is equal to 0. So for x is equal to, here we have 1x and 5 coordinates, and when I put x is equal to 0, I get 3. So the conclusion is this one: if the graph of y against x does not pass through the origin, then y is not directly proportional to x. It may be still linearly related, but the presence of a non-zero, if this is not equal to 0, non-zero intercept indicates that the relationship includes an additional constant term and is thus not a directly proportionality. Question number 4. As x increases, y also increases. Can we conclude that y is directly proportional to x? No, we cannot conclude that y is directly proportional to x solely based on the observation that y increases as x increases. So here is the detailed explanation. Here we will deal with direct proportionality versus positive correlation. For direct proportionality, in our algebraic definitions, I told you that if y is directly proportional to x, then y is equal to kx per some constant k. This relation implies that the ratio y by x is a constant for all value of x and y. Okay, so in graphically, I come to know that its graph will be a straight line that passes through the origin. This is for direct proportionality. Now for positive correlation, its definition is this one, like y and x are positive correlated if x increases as y increases, y increases as x increases. This means there is a general upward trend in the relationship between x and y. Graphic characteristic, the graph of y against x shows an upward trend, but it does not necessarily pass to the origin, and the relationship does not have to be linear. Now why the positive correlation does not imply direct proportionality? Now non-linear relationship. It will be non-linear relationship. Y could increase with x in non-linear manner, such as y is equal to x square. Let's see its graph using GeoGebra and discuss it there. This is the function y is equal to x square, and you see that as x increases, y increases. For x is equal to 1, it is equal to y is equal to 1. You can see. And for x is equal to 2, y is equal to 4, and similarly for x is equal to 3, this y is equal to 9, and for x is equal to 4, it's equal to 16, and similarly for 5, it will be equal to 25. So y increases with x, but the relationship is quadratic. It's not linear equation. This relationship shows positive correlation, but it is not a straight line and thus not directly proportional. Now, linear relationship with intercept. So y could increase with x in a linear manner that does not pass to the origin, such as I told you a few minutes ago. I have given you an example that y is equal to kx plus b, or I told you that 2x plus 3. So we came to know that that wasn't passing to the origin. Again, let's see the graph using GeoGebra. Earlier in our example, y was equal to x squared. In that equation, the relationship between y and x wasn't linear. That was quadratic or parabolic. Now here we have a linear relation, but with intercept. So in linear relation with intercept, y could increase with x in a linear way. That does not pass to the origin. You can see, and also x increase, y increase. Let me show you table of values, and here for x is equal to 1, it's y is equal to 5, and for x is equal to 2, we have y is equal to 7. For x is equal to 3, y is equal to 9. For x is equal to 4, y is equal to 11, and for x is equal to 5, y is equal to 13. So x increase, you see, x increases with y, but the line does not pass through the origin, and thus it is not direct proportionality. And another like exponential relationship, y could increase exponentially as x increases, such as y is equal to a to the x. Now for a is always greater than 1. For example, y is equal to 2 raised to the power x. And for our convenience, we will now switch over to GeoGebra to see its graph. So let's go there and see how this y is equal to 2 raised to the power x behave. So this y is equal to 2 raised to the power x exponential function is like this one. And let me show you the table of values. For 1, it returns 2. For 2, it returns 4. For 3, it returns 8. And for 4, it returns 16. For 5, it returns 32. For 6, it returns 64. For 7, it returns 128. For 8, it returns 256, and for 9 it returns 512, and for 10 it gives us 1024. And this is the graph. You can clearly see that it's a curve or an upward trend. Y increases, you see, Y increases, X increases. But the relationship is exponential. It's not a straight line. So the conclusion is this one. When n increase in Y with n increase in X indicates a positive correlation. Okay? It does not specify the nature of the relationship between X and Y. Direct proportionality requires a specific linear relation that passes through the origin, characterized by a constant ratio of Y by X. Therefore, without additional information confirming this specific linear relationship, we cannot conclude that Y is directly proportional to X. I hope this would answer the question. If you like it, do subscribe my channel and see you in next video, inshallah.